Good afternoon, students. In the last video, we have discussed about the operation of union, and we had also seen that what is the union of two sets A and B. Now we will discuss about some properties of the operation of union, and in which first property is given as A union B is equal to B union A, where A and B are non-empty sets, and this property is called commutative property, commutative law or commutative property, because A union B is the set obtained as the same as B union A. It means the operation union is commutative in the sense of sets. And similarly, second one is A union B and union C is equal to A union B union C, and this is called associative property or associative law. Associative law. And third one is A union phi is equal to A, where phi is the identity of U, and this law is known as law of identity element. This is called law of identity element. And fourth one is A union A. A union A is equal to set A, and this is known as idempotent law. Idempotent law. It means if we take the union of A with itself, then we get the same set A, and this is known as idempotent law. And last one is U union A is equal to U, and which is known as law of universal set U, where U is a universal set. And we will use these properties to solve the problems based on operation of union. And after this, we will discuss about intersection of sets. Intersection of sets. Intersection means intersection of a set is the set in which there are common elements of the two given sets A and B, and we can define the intersection of sets the intersection of sets capital A and capital B is the set of elements which are common to both A and B, and we use the symbol this type of symbol is used to denote the intersection. It means if there are two sets A and B, then the intersection of A and B, symbolically we can write A intersection B is equal to set in which the elements are such that X belongs to A and also X belongs to B, because we take those elements of set A and B which are common in both the sets. Suppose that we will try to understand the intersection of sets with the help of an example. Consider we take two sets. Let A is equal to 1, 2, 3, 4, 5, and another set B is equal to 2, 3, 2, 3, 5, 9. Therefore, A intersection B is a set in which there are those elements those which are common in both the sets A and B, and we can see that 2 is common in both the sets, 3 is also common in both the sets, and 5 is also common in both the sets. Then A intersection B is equal to 2, 3, 5. And with the help of Venn diagram, we can also represent the intersection of sets. With the help of Venn diagram, we know that if there are two sets A and B, then A intersection B can be written as X such that X belongs to A and X belongs to B. Then if we represent this statement, the intersection of two sets A and B, then we have to draw a Venn diagram. If U is a universal set, then we know that universal set denotes a rectangle. This is a universal set, and let us consider there is a set A. This is set A, and this is set B. Then the region which is common in both the sets will denote A intersection B. because if we take any element lying in this region, belongs to this set A and also belongs to the set B. Therefore, this shaded region represents A intersection B. Again, we discuss about properties of operations of intersection. There are also some properties of operation of intersection. Operation of intersection, and in which first property is also commutative law, and we can write A intersection B is equal to B intersection A, and which is known as commutative law. Commutative law. Second one is associative law, and we can write A intersection B and intersection C is equal to A intersection B intersection C, and which is called associative law. Associative law. And third one is phi intersection A is equal to A. Phi intersection A is equal to A. Phi intersection A. Phi intersection A will, because we can see that there is no common element in phi and A, therefore this will be phi. Phi intersection A will be phi, and also U intersection A will be A, and which is known as law of phi and U, universal set U. And fourth one is A intersection A is equal to A, and which is known as idempotent law, as we have discussed before. Idempotent law. And there is another law, and which is the last law, last property of operation of intersection, and which is given as A intersection B union C is equal to A intersection B and union A intersection C. And we know that this property is called distributive property. Then this is distributive law. And we can also see that the operation intersection distributed over union, because this is the symbol of This is the symbol of intersection and this is the symbol of union, and we see that this symbol distributes over union, because here A intersection B and union A intersection C. This will be A intersection C. And in the next video we will see how to represent these properties with the help of Venn diagrams. And we will see in the next video lecture the difference of sets and the representation of properties of operation of intersection with the help of Venn diagrams. Thank you, students.